Hey everyone, this is lesson 1122 on surface area and volume of a cone. Prior to this lesson, we've talked about volume and surface area of a few other three-dimensional shapes. Let's review some of the prior knowledge that you should know coming into this lesson. And then maybe if you don't remember this stuff, hopefully this helps. But for the most part, we have volume of a prism and cylinder. Let me highlight these for us. So volume of prism and cylinder, we have a formula for that. Volume equals base area times height. Remembering that when we talk about, make sure you're using this capital B to represent the area of the base shape. And that base shape could be really any shape. It could be a square, rectangle, trapezoid, circle. That really could be anything. So if it's not a circle, then most likely we're talking about a prism. But if that base shape is a circle, then that's when we call it a cylinder. And the height is really the only thing we need from the actual prism or cylinder when we're calculating the volume or surface area. And so when we look at surface area of this same type of shape, we have surface area is 2b, this capital B again is the area of the base, plus the perimeter, this capital P is perimeter of that same base. So if it's a square, rectangle, circle, whatever the shape is, we're going to find the area and we're going to find the perimeter of it. And then again, the only thing we need from the prism or cylinder is that height as well. So those are two simple versions of those volume and surface area. More recent lesson, we talked about pyramids. And in this case, we mentioned that the formula is almost the same for volume, except we have this 1/3 in front. And that's because really the pyramid is 1/3 the size of a prism that has the same base and the same height. So if we compare them, the same base and height, right? If the bases are the same and the height's the same, then the pyramid, the shape of the pyramid, is going to be 1/3 of that. So we just have to multiply it by 1/3 or divide it by 3, and that should give us our volume. Now, surface area, I didn't go into too much depth on the previous lesson because we're going to talk more about it today when we talk about cones. And so, because the reality is it's going to be the same formula for cone, which I'll mention in a minute. But let me just kind of explain this one really quick. Remembering your different parts of a pyramid, if you remember correctly, we have one base, right? Unlike the prism that has two, top and bottom, there's only one base, right? In this case, the picture represents a square. It could be, again, a rectangle, triangle, hexagon. It could be a variety of shapes as well. But we're going to focus only on square-based pyramids in this lesson. And so if we want the surface area, we want to find the area of the base again. So it always comes back to knowing how to find the area of the base. This is different than the prism, where you'll notice there's actually two of them, right? Top and bottom. That's why we multiply by 2. With the pyramid, we only have one of them. So even if you could put a 1 in front of here if you want as well, just to let you know there's only one base instead of two bases. The second part to this is the lateral area. Now technically, P times H, perimeter times height, is also the same thing as lateral area. So this is lateral area, which represents just the area around the shape that does not include the base. So that's what this lateral area means. It means the area all around the shape except the base, right? So I don't want the base. So why? Because I'm adding it here. And you'll notice that the base shape is different than all the shapes around. In this case, these are triangles that go all around. So it's going to be a lot easier for us to focus only on the triangles that go around the shape and add up all those. So if we could add up all those lateral faces, that'll give us the lateral area. And we're going to practice that in this lesson as well. So, but first let's talk about volume. And so the nice part about cones is they're the same as pyramids. So just like cylinders and prisms were pretty much the same except for the base shape, it's the same thing for pyramids and cones. So you'll notice a lot of similarities. They both have an apex, a little pointy top. Both have one base. You'll notice the pyramid has one base and the cone has one base. The only thing that's changed is the base has changed to a circle. So when it does change to a circle, you'll notice all these triangles that we had on the pyramid are no longer there. This actually gives us a smooth lateral area, which means there are no triangles we could find the area of. So the way we find the lateral area is going to be a little bit different. And so I'm going to give you some formulas for that to make it easier. But when we talk about volume, well, the formulas are going to be the same. And so it's still going to be 1/3 base area times height. So when we talk about a cone, you could imagine that this cone really came from a cylinder. And so the cylinder is going to be 3 times as big as that cone, which means the cone inside actually takes up 1/3 of the cylinder. So if I fill up that cone with water, it's only going to fill up 1/3 of the cylinder, which means I could fill it up 3 times before I actually fill up the cylinder. So this formula is going to be the same. The only thing that changes is when we find the base area, we're going to use pi r squared to find that, instead of maybe for a square where we would multiply the length times width or base times height of that square. So we're going to practice a couple of problems so we can see the difference. I've set these up for us. It makes a lot more sense with numbers, so we're going to look at both of these and see if we could calculate these. All right, so the first one, we'll do the pyramid first. So we already know the formulas, right? We know the formula for volume is 1/3 base area times height, which means I really want to figure out the base area and I want to figure out the height. Those are the two things I want to make sure I identify first. So common mistake here, some people will say, oh, 8 is the base, so that's easy. And then 8 times 3, that's not the case. So don't forget, base area refers to the actual area of this bottom shape. So that means we need to know the base and height, or length times width, of this shape. So the nice part is it's a square, so I'm going to actually multiply. We're going to use, let me use a different color here. So I'm going to multiply 8 times 8 because, again, it is a square. So this is going to give us a base area of 64 inches squared. All right, and then the height of this pyramid is given to us. So this is going to be 3. I don't have it in the picture, but I'm assuming those are 3 inches. And so that's all the information we need, and we're just going to plug it in. So 1/3 64 times 3, and we would multiply that out to get our answer. All right, so let me change color here. So this is volume. So I mentioned this before. You can multiply these in any order you want. I always like to see if any one of these is divisible by 3. That way I could get rid of the fraction. So 1/3 of 3 is equal to 1. So the reality is this is the same as 1 times 64, which means this is 64 inches cubed. All right, so that's how you find the volume of a pyramid. That's just a review for you. That's what we did last lesson. Now, with a cone, how does this change? Well, here's the picture, and you'll notice I kept the measurements the same. This height is still the same, and you might not notice it, but the width of this, the diameter, is actually 8, which is the same as this measurement here, right? The width of it is 8. So how does that change? Well, if I want to find the base area, which is the bottom part here, so if I want to find the area of this, I need to use that formula I just mentioned. Base area is pi r squared. So I'm going to utilize that. So pi r squared. What is the radius in this picture? Well, it's given to us. I put the radius as 4. So that's 4 inches. And so if I want to find the base area here, I would do 4 squared, which is 16 pi. And this is going to be inches squared. All right, and then the height of this cone is, again, 3 inches. And I would put those numbers in. Same formula for volume, except you'll notice, don't forget that pi in your answer. And we'll do the same thing here. And let's simplify this. So 1/3 and 3 reduce again, basically the same as the other one. So I have 16 pi, and then that's, if I was going to write this answer out, I would leave it in exact form, which would give us inches cubed. So 16 pi inches cubed. If we actually multiply this out, this 16 pi, or yeah, 16 times pi, that's like 16 times 3.14. So let's see what that comes out to. 16 times pi. All right, so that's approximately volume equal. Let me do squiggly lines. Approximately equal to 50.27. Oops, sloppy there. 50.27 inches cubed. All right, so definitely there's a difference there. The cone had less volume than that pyramid. All right, so that's kind of the general idea of how to find volume with a pyramid and a cone. You can see that it's basically the same. If I ask you for an exact answer, make sure you're prepared to leave your answer in exact form, which would be 16 pi. All right, so those would be good answers for both of those. All right, so now really the more challenging part is surface area. And so a pyramid and cone use the same formula. So that's the nice part. Just like for volume, they're going to use the same formula. So for us, that's going to be base area, that's that B, plus lateral area. So we need to find two things, the base area of the base, and we need to find the area of all the sides or the faces. So that only difference that's going to change is the base shape. So with the pyramid, it's going to be maybe a square, versus with the cone, it's going to be a circle. So, and when that happens, that changes the lateral area shape as well. So let's look at an example of that. So here is kind of like the general structure of what we're looking at. So we're, like I said earlier, we're going to focus on square-based pyramid. So just to make that easier. So definitely you need to remember all the parts. So obviously we talked about the base being the bottom of the pyramid. But some other terms we're going to need in this case is the base edge. So the edge is actually talking about these lines that make up the base, that go around the base. So in this case there's 4 edges. And then there's a slant height that we need to know, which that's the height of the triangles that make up the sides of the pyramid. So I need to know how tall these triangles are. So that's going to be the slant height. And then the triangle itself is actually called a lateral face. So in this case, there's actually 4 lateral faces. There's 4 triangles that go around the pyramid. All right, so that's the understanding that you need to have when you find the surface area of a pyramid. So in this case, if I want to find the area of the base, well, we already said it's a square. So that means I'm going to take the base edge, which I said was a lowercase b, and I'm going to square it. So I'm just giving you the structure of how the work's going to look. There are no numbers here, so there's nothing really to calculate. With lateral area, I'm going to put L area so we know it's the lateral area. What I've done here is, like I mentioned before, these are all triangles. So if I think about the formula for the area of a triangle, right? So this is area of a triangle. Right, so all the lateral faces happen to be triangles in this pyramid. So that means I need to basically find the area of one triangle, and then I'm going to multiply it by 4. Why did I multiply it by 4? Well, that happens to be, this 4 happens to be the number of lateral faces. Right, the number of lateral faces, which is also happens to be the number of base edges. So you'll notice there's 1, 2, 3, 4 base edges because there's actually 4 triangles, right? There's 4 triangles that go around this whole pyramid, right? All right, so if this happens to be like a hexagon base pyramid, then that number would change to a 6. So this is not always going to be a 4, but it will be a 4 if it's always a square base pyramid. All right, and then surface area is just adding these two together. So once you've calculated these two, all you have to do is add them together, and that's your total surface area. So same idea with a cone, except there's a lot less. You'll notice there's a lot less going on in this diagram. This is why I really like working with cones and cylinders. It's just anytime there's circles involved, it becomes so much easier. Because all we really need to know is the radius. So if we know the radius, right away it's going to give us an easy way to find the area of the base. And then the only other thing we need is the slant height. All right, not even the height of the cone. That's for volume, but when we're talking about surface area, we want to know this distance on the side. And so this measurement is called our slant height, just like it was called in the pyramid. And that's going to help us find the lateral area. Now, there's an explanation. Usually, if I'm in class, I would give a visual of how this formula comes about. And I think it's really interesting to know. If you have a chance to look it up, or if I find a video that explains it really well, I'll try to share that with you. But for the most part, what I'm going to do is I'm just going to give you the formula that helps us find the lateral area. So for base area, we already know it's going to be pi r squared. For lateral area, it's going to be pi times r times L. And in this case, your L is your slant height. So these are the only two numbers we need for lateral area, and you'll notice for base. So that's the nice part about the cone. And then surface area, we're just going to add those numbers again together. So most of the work is going to be occurring here, finding the base area and the lateral area. If anything, lateral area is the most work. All right, so let's do this with numbers, and then I can see test out whether you're getting these correct or not. All right, so let's start with the pyramid. I'll zoom into the pyramid for right now. So let's calculate the surface area of this shape. So we're going to start with the base area. So that means we want to know what's the area of this base on the bottom. All right, so let's see if you can tell me that. So I'm not even going to set this up for you. I'm going to see what you come up with. Final answer for the base area. I'm going to set it up for myself because I'm telling you I'm going to multiply two numbers and I'm going to end up with the final answer. So let's see what you come up with as your final answer for base area. And don't forget your units on these. This is inches squared. If you don't have units, it would be considered wrong. Okay, so let's see if you put the right number in. We are looking to add, or we're looking to multiply 8 times 8 in this case, which is going to be 64 inches squared. All right, so there's the base area. Now lateral area, this one's a little bit more tricky. I'll help you set this one up, but usually when I start this, I ask myself, how many lateral faces are there? So how many triangles are there that go around the whole pyramid? Well, in this case, there are 4. And so then that means I'm going to find the area of the triangles. Just one triangle is going to have a formula of 1/2 base times height. So that means I need to figure out what numbers go here. So those are going to come from the picture. Make sure they're the right numbers, though. It's not always obvious. And so if it helps, I would probably suggest making sure you know what triangle you're focused on. I always like to highlight the one on the side instead of in front. I'm not sure why, it just makes more sense to me. But this, imagine we're trying to find the area of this triangle. So the question is, what's the base of this triangle? This is the measurement we need to know. Well, this is the base edge, which happens to be the same as this measurement, which is 8 inches. All right, so that means I know I'm going to include an 8 here. And I also need to know what the height is of this triangle. So how tall is this triangle? The slant height has already been given to us, so that's nice. So I'm going to use that number to calculate my lateral area. So there's the numbers. Let's see what you come up with to solve this. So you could do it in steps if you want. But either way, I want to know what your final answer is. I actually might write it in steps, but I want to know what your final answer is. Don't forget your units. This is area, so it would be inches squared, so make sure to include that in your final answer. All right, so first thing I'm going to do is, I like to always leave the 4 last, but I like to simplify the triangle area first. So 1/2 times 8 is 4, so that's 4 times 5 that I'm looking at here. So 4 times 5 is 20. So this is going to be 20. And so now I'm looking at 4 times 20, which is 80 inches squared. All right, so there's my base area and lateral area. And so if I want to find surface area, this is the fun part, because all you have to do is do 64 plus 80. Right? It's that easy. So surface area is 64 plus 80. Hopefully you just throw that into a calculator. Even if you could do that in your head, I would still recommend using a calculator, just because um, more often in a problem like this, I'll notice more people will do calculation errors in their head uh, than on a calculator. But it's your choice. So 144 inches squared. We're still talking about area here. Remember, this is not volume, so make sure you get your units correct. All right, so that's the general idea. Hopefully that makes sense with pyramid. So with the cone, same idea, except the only thing that's changing is our formulas for base area and lateral area. So let me zoom into this shape. All right, so we need to know, I already have the formulas for us written here because obviously it's new for us. But if I'm going to calculate this, I need to know what the radius is, and I could plug that in and calculate that. And then lateral area as well. I'm looking to multiply radius and slant height. So there's a little bit of an issue on this problem, and this is kind of a tip. This is typical of this problem, and that is sometimes the information we need is not given to us in the problem. So it might not be so obvious, but I'll start us off with the first part, which is base area. The radius is given to us as 4, and I could actually plug that into lateral area as well. And so it's no secret that this is going to be 16 pi. And this is inches squared. Lateral area is what I'm more concerned about here, because common mistake, probably if I just asked you and you rushed through this, if I asked you, well, what's the slant height? What number goes here? I could almost guarantee a good majority of you are going to put a 3 here, because it's that's the measurement that's given to us. So this is where it becomes important for you to know what you're solving for and to know all the parts of these shapes. So 3 happens to be the height of the cone. It is not the slant height. So be careful there. In this case, h equals to 3. We want to know what the slant height is, which happens to be on the side. So we want this measurement. Well, if you notice, we have this triangle that's kind of created here. If we slice this cone, we actually have a triangle here where one measurement is a 4 and this one is a 3. So you should know that if this is a right triangle, you should be able to calculate the hypotenuse of this triangle. And so I could very easily ask you, which right triangle tool can we use to find the slant height? We've seen this on a number of problems recently. This is going to be a Pythagorean theorem problem. So we would have to set up a problem where we have 3 squared plus 4 squared equals 2. We'll call this L squared, which is our slant height. And then once we calculate this, we're going to end up with L equaling to 5. All right, so this is the number we're going to put in here. So if the number was given to us, then we wouldn't have to worry about all this. If it's not, then you always make sure to see, can you calculate it? And almost always, you're going to have the other two sides so that you would use Pythagorean theorem. So keep that in mind. All right, so that means our lateral area, oops, wrong color. Lateral area is going to equal to 20 pi inches squared. All right, so now I'm going to ask you, hopefully you could do this easily. is what is the surface area? So I'm going to set it up. I'm going to have a final answer down here, but I want you to tell me what the final answer is. And leave your answer in terms of pi, no decimal answers, just in terms of pi to make it easier. And don't forget your units. You should have inches squared still on your final answer. All right, so let's see if you set this up correctly. So this is going to be 16 pi plus 20 pi, right? That's it. Just add those together. So 16 plus 20 gives us 36 pi inches squared. All right. So we took our base area and our lateral area and we just added them together. All right. So for both surface area of a pyramid and surface area of a cone, you'll notice the process is pretty much the same. This just focusing on the right shapes, and you still need to know how to find the area of a circle, triangles, squares. That's kind of the foundation of all this. So that's pretty much it for now. There's harder versions of these problems, but I'm sticking to the basics. And so hopefully these are good enough notes that if you're working out problems, common problems with pyramids and cones, that most likely it's going to be some version of these. So let me know if you have any questions, and we'll see you next time.